Form should follow function, and that's certainly true of the inland concrete pipe manufacturing facility. This state-of-the-art structure was built from the ground up with concrete pipe production in mind, and it's the first of its kind in North America.
This building was very challenging to design from the inside out. The client had come to us with a set plan in place, a manufacturing process that had certain pieces of equipment and a certain layout. And those pieces of equipment related to each other. They had certain constraints that had to be maintained, tolerances between the equipment that had to be maintained. So the construction and the design of the building was all around the equipment. If we couldn't maintain the tolerances required, there would be large problems with how the equipment operated, and this plant is fully automated. So we needed very tight tolerances in order for the equipment to operate from one process to the next in a continuous flow.
The advantages of steel are schedule-wise, and it's very important on this job. The vendor equipment was scheduled to come in December of that year, and we had to be ready for their structure in time, so it's very important that with the cold weather that we'd be able to continue our construction.
This breakthrough facility is making its mark in concrete manufacturing with the help of steel construction. The Inland Concrete Pipe Manufacturing Facility is an outstanding finalist for the CISC Alberta Awards Industrial category. Modifying an existing structure can present an opportunity for innovation. The demands for the Shell Canada energy reactor building modifications led to an inventive solution that maximized utility and minimized modification.
The project had a very fast-track schedule. We had to complete design, fabrication, and erection within about a 6-month period. The erection of the structure took about 6 weeks. Steel started arriving on site in early February, and the cranes were commissioned during the last 2 weeks of March.
I think some of the challenges that we encountered early were the fact that we dealt with a building that was existing. We had to do a fair amount of on-site survey to determine the location of the existing structural members, the position of electrical, mechanical, and that all tied in with the fact that the client really wanted to maximize that footprint. So we needed to, I guess, balance the client's need to maximize that footprint with where things were.
Creativity, innovation, and cooperation are the hallmarks of the Shell Canada energy reactor building modifications, making it a fitting finalist in the CISC Alberta Awards Industrial category. Working on an engine while it's running can be tricky. The Supreme Steel Bridge Division plant expansion had to be done while the facility was still in operation. This called for some creative solutions and some research.
Steel was an important component on this project for a couple of reasons. Number one, the spans were long and the loads were very tremendous. The loading that we had to design for were for 4 40-ton cranes running in tandem. That's about equivalent to about 3 times the weight of the design vehicle for designing a typical highway overpass.
Some of the design features of the project in our runway would be the long span girders we had to fabricate to support the building structure for the existing runway, and as well as the crane runway itself. With that, we've used 2 girders, 100 feet long, erected them with a 100-foot opening to transfer our material from our south runway through into the existing shop. We were able to complete this project while still fabricating and really not missing a beat in the shop. We're able to create the girders, erect the girders, and continue fabrication on the bridge projects we had in our backlog.
Upgrading an existing structure with 0 production downtime is a remarkable achievement. It's one of the many reasons why the Supreme Steel Bridge Division plant expansion is a worthy finalist for a CISC Alberta Industrial Award.